Okay, so I'll run over my SCADA screen for Lab04. So I'll just start off here in the tag manager. So I created a total of 8 tags to be used in this lab. So we have the panel, input pump, pH sensor, flow sensor, pressure sensor, osmosis membrane working, output tank level, and contaminant pump state. So these are all put here in the tags. I'll then go over the alarms. So we'll start with the contaminant pump state again. So I just have the compare value for this. I'm going to put them as 0 actually. Put as 0. So for the contaminant pump state, the input pump state, the osmosis membrane working, as well as the panel output. So in terms of these 3, 0, 2, and 3, these are all just going to really give the state of the device if it's on or off for the sake of this lab. So I have the compare values set to 0. So anything above 0 will give an alarm. However, really the alarm is just telling us that the pumps or the osmosis is working. I have a flow sensor and I just have that value set to 0 for the sake of this. The output tank level, in real application, there would just be some sensors to tell the level of the tank. I just have it set to the max volume right now. And it's above this volume, then we'll get an alarm of 100. In terms of the panel power, I just have the compare value here set to 0. This will just tell the output value of the panel. So if the solar panel is working and producing power, this would just give the overall power output that will be going into the pump. Followed by, we have a pH sensor and a pressure sensor here. So these would just be alarms with 7 and 75 arbitrarily set for those values. So now in terms of the screen, so this is a screen I have. This is just some alarms from testing earlier, so we can just ignore those for now. Just to go over a quick run through, have the input tank, pH sensor, input pump, pressure gauge, flow meter into the membrane series. I'm just using one series, one membrane for the sake of this. However, you can have multiple series and series that are parallel. That contaminated output valve, pressure gauge, flow meter, pH sensor, followed by the output tank, and the PV right over here, which will provide power to the system. I just have it going to the pump for now, but it would actually power the entire system. And then finally, I have a controller up here. And this would be used to really turn the entirety of the system on or off, and I also have an emergency stop, and also just be able to provide like an indicator light or something of that nature in order to tell the system. It's kept pretty simple, just to limitations of the version of the design we're using. Before I go in and go to the values, I'll just run to my report quickly. Just scroll down. So the SCADA screen was really built off of this block diagram, as well as the P and ID diagram I have created here. And there are some slate modifications just due to limitations again in the program. For example, I've left out the pressure release valves in this case. However, really, if there's too high pressure, these pressure release valves will be activated and help equalize the pressure in the system. We have the sensors going through there, 2 membranes in this case. Like I said, I'm just going to go with 1, but this is really where the design came from. And then the PLC ladder logic here. So again, this just includes most of the inputs that I just mentioned, as well as some outputs to really indicate what's happening in the system. So in the first rung here would be general generator start, which I just mentioned. And so operator would have to have that input start activated first in order for the system to run at all. And that's just really a safety measure. Next, I'll have a pump input. So this would just be controlling the pump. If there is power coming in from the solar panel and the operator of the system turned on, we'll be able to get the pump running. And then if the pump's running and we have good pressure, good pH, and good flow, we go to this third rung here with the outputs. One, that the system is running and the osmosis machine is working. And we would also have the contaminated pump system would be active here as well. So if the system is running at all, we would also need the contamination pump or valve running to let that out of the membrane and help drain the system. Into the force rung, we have the pressure release. So this is just if we have too high of a pressure, the pressure release will be activated to just really ensure safety again on the system, that the pressure don't get too high. And then finally, the last rung just shows an output indicator just to show is the entirety of the system running or is something wrong in the system. So to go through quickly, I'll just run through using these input values here, and then after I'll run through going from Modbus to the system instead. So I'll just start here with the pH sensor. Right now it's 0. If I go to 5, we don't get a new alarm as that is a good value. However, if we go to 9, we will get an alarm as that's too high for the pH. And the same is of the sensor. Right now they're hooked up to the same input just for simplicity of this project. Then the input pump, so right now it's a 0, so that just says like the input pump is not running. If we go in and put on a 5, we will get an alarm. However, that's not really an alarm saying anything is wrong. Just for the sake of this design, I used an alarm to show, okay, the pump is actually turned on, even though this would just be a simple Boolean on or off. And instead, you can have different values for the input pump, like the power it's using, if it's in good rating, or different things like that. And then the pressure gauge, so this would be a sensor from the system that the gauge would read of the pressure. So I'll put in 90, and we should get an alarm. We will not get an alarm. Why are we not getting an alarm? Oh, there we go. This is the one that's hooked up because they're linked together. So we have an alarm because the set value is 75, and we're putting in a value of 100, and that just says the pressure is not equal, shut off the machine. Then we have the flow meter. If we type in 60, we're all good because it's set to 75. So if we go to 80 or so, should be getting an alarm. Then if we go down to the contaminated output, so again, this would just be a Boolean in real application saying on or off, but right now it's just set to show an alarm if the value is above 0, and that really just says that the system's running. And here are the flow sensor alarms that just came through. And again, they're linked. The pH was linked. As the output here, we have the output tank. So this would have a series of sensors in order to tell the tank level. However, in our case, we're just going to show is the tank at the maximum level. So if the tank level measures 90, we're not going to have an alarm. However, if we go up to 101, we will get an alarm as the max level is 100 and the tank is at the maximum volume. So an operator would have to go in and work on this system running indicator and manually turn the machine off. And then finally, entering the values into the SCADA system, we have the PV array. So this here would just tell the power output from the PV. So I'll just type in 63 for now, as there's no alarm associated with this for max or min value, as we just want to know the power output to ensure that it can run the pump. And also in real application, there would be like some type of limit switch here. And if the PV array output is not above the limit, the switch would be open, because we wouldn't be able to run the pump because there wouldn't be enough power output. It would need to exceed a threshold value in order to turn the pump on. So then going from the Modbus over to the system, I'll just run through the different addresses here and show how they reflect the values on this side. So first we'll start here. So first we had a value 63 at the PV. So I'll just put in a value of 90, and it appears over here. So here we have the input pump. That one is linked for now. I'll just put the value back down to 0 and we're turning the input pump off technically. If we go to the flow meter, so this is just measuring, and I'll just put it down to 60, which is a value that we would like. Again, for this one, we'll just pop it down to 80. This one here, we can also pop down to 80. So let's just see the pressure gauge. Value 5, we can pop in a value of 8. Here. We'll go over to this one, which is the output tank. So we'll just put it down to 60 again to show it's at normal level, and that's appearing. And finally, this value here, we have a 6 at the contaminated output. We can put it down to 1. And that's everything.